Hey everyone! In today's video, we're going to be taking a look at how to configure a site-to-site VPN using WireGuard. Now, throughout the course of this video, I will be accomplishing this configuration using the OPNsense firewall system. However, at the same time, I'll try and do my best to share what the standard WireGuard config files look like as well, so that if you're working with either a peer that isn't OPNsense, or if you're just doing a site-to-site VPN with just two plain standard native WireGuard peers, you're going to be able to accomplish that configuration just as well. So with that said, let's just go ahead and jump into it. And the first thing I'll show off is going to be the topology that we're going to be working with today. So for this setup, I wanted to show a couple of different configurations. So we'll be working with 3 locations, a corporate site, as well as 2 remote sites. The corporate site is going to have a subnet of 10.60.60.0/24, with a file server hosted at .10 that we're going to be able to access over the site-to-site VPN once we get everything up and configured. Then we're going to work with 2 remote site firewalls connecting back to that corporate headquarters. For site 1, we're going to be using the subnet 10.100.100.0/24, and this site is going to do split tunneling or partial tunneling, where the intent is from site 1, the only traffic traversing that tunnel is going to be 10.60.60.0 for the corporate headquarters. And the reverse will also be true. So from the corporate side, the only thing we'll pass is that 10.100.100.0. Now, what this will mean for site 1 as well is that since we're only tunneling the corporate headquarters traffic over that VPN, all internet routed traffic will still go out the direct internet connection for site 1 and will not traverse that VPN tunnel. So for site 2, we're going to be doing just a little bit of a different configuration. In this case, we will be doing a full tunnel, so all traffic, all routes will be forwarded over the WireGuard VPN to the corporate headquarters. This means both traffic to the 10.60.60.0, as well as all internet-facing traffic. So to accomplish this, we will have a little bit of additional configuration to make sure that that traffic is routed through the corporate firewall and out to the internet appropriately. And so with all of that said, let's just go ahead and get into the setup. And we'll go ahead and start with the corporate headquarters firewall. All 3 of these firewalls are running OPNsense, and they are running the current release as of today, which is 23.1.5. And since we're on the corporate side, before we get into the WireGuard config, I will just bring up the Ubuntu VM that we're using as a demo file server for the moment. I've installed a piece of software called Miniserve here, which acts as a web-based file server. So once we get our VPN tunnels up and configured from our remote locations, we should be able to hit this file server remotely and access these dummy data files that I uploaded. Now, we'll also bring up the Site 1 client PC real quick, and we'll go ahead and test access right now to ping fileserve.0x2142.local, and that does resolve to the 10.60.60.10 address, and sure enough, right now we cannot reach that. So we can start by configuring WireGuard on the corporate side first. And the first thing we'll do is we'll go down to VPN and then down to WireGuard. Then we'll enable the WireGuard service. Then we'll go ahead and hop over to the local tab. This is going to have the configuration for the corporate firewall side of the WireGuard configuration. So we'll go ahead and hit the plus to add a new configuration. We'll name this Corp HQ. We'll leave the public and private key blank since these will be auto-generated when we save the configuration. The default WireGuard port is 51.820. However, we can manually specify that here or opt to change it if we like. And we'll also set a tunnel address of 10.99.99.1. The tunnel address is going to be the address that is assigned to the WireGuard tunnel interface when it gets created. And this is going to be what will be used for VPN communication between the different peers. And speaking of peers, right now we have no peers configured, so we're not able to set anything here. So we'll go ahead and save this for now and click apply. And then we can go back and edit that configuration and see that now our public and private keys have been auto-generated. We'll go ahead and copy the public key, which we'll need to configure on our remote site peers. And we'll hop over to the Site 1 OPNsense firewall. Similarly, we'll very quickly jump down to VPN, WireGuard. We'll enable the WireGuard service. And then this time we'll hop over to endpoints real quick. And we'll set up the endpoint configuration for the corporate firewall first. So we'll go ahead and hit add, and we'll name it Corp HQ again. We'll paste in our public key. For allowed IPs, This functions as like a filter or access list for what traffic should be allowed across this VPN tunnel to this peer. So for example, on the corporate HQ side, we just want to be able to access that 10.60.60.0/24 subnet. So on our Site 1 configuration for allowed IPs, we will put in that corporate HQ subnet. This will automatically add a route within the OPNsense configuration to route traffic to that subnet over our WireGuard tunnel. Now you might have seen in the local configuration on the corporate HQ side that there is a setting for disable routes. If for whatever reason you did not want WireGuard automatically adding these routes, for example, maybe you have a bunch of subnets behind each firewall and you wanted to use a dynamic routing protocol rather than using OPNsense's built-in static routing, you could check that setting, but then OPNsense would not install that route and you would have to do that via another method. For endpoint address, you can put in the IP or host name of your remote firewall. This is going to be the externally accessible address that we're able to establish that VPN tunnel over. And so I will set this as corp-hq.0x2142.local. And last but not least, we can also specify a keep alive interval if we like. Now, because of the way that WireGuard works, there isn't necessarily a tunnel establishment and need to keep those tunnels alive and online like you might see with a traditional IPsec tunnel. Instead, WireGuard just encrypts and decrypts using the public and private keys, and traffic comes and goes as it pleases, and there's no need for an underlying tunnel to be established. However, if you wanted to set up any sort of monitoring where you want to ensure that the last handshake received time within WireGuard is always up to date and shows that the tunnel is still active, you can go ahead and configure a keep alive interval here, where then the WireGuard software on OPNsense will intermittently send a packet across that tunnel to the remote peer to try to keep the connection updated. The WireGuard documentation, I believe, does actually specify that they recommend if you're going to do this, set it to 25 seconds. So we'll go ahead and do that here. Once we're done with all of that, we'll go ahead and hit save and then apply. And similarly, since we're here, we will configure the local side config as well. So we'll go to the local tab, set the name to Site 1. We'll set our listen port. We'll also set a tunnel address of 10.99.99.100/24. And this time we can select our corporate HQ peer since we did already configure that. And we'll hit save and then apply. Now we can grab our public key out of the Site 1 configuration and mirror that configuration on the corporate side by creating a new peer for Site 1. And so again, we'll go to endpoints, hit add, name it Site 1. We'll paste in our public key. And this time again, for our allowed IPs, we will only set the subnet for Site 1, which is 10.100.100.1/24. Endpoint address is going to be the hostname I have set up for Site 1, which is site1.0x2142.local. And we'll set our keep alive and then save and apply. Last but not least, we can go back over to the local config and add our Site 1 peer to the WireGuard tunnel interface. So in order for those tunnels to establish between those two locations, we do still have some outstanding OPNsense configuration that needs to be done. The big one being creating a firewall rule that allows that port 51820 traffic into each firewall. Right now that's being blocked, so the tunnels aren't able to establish appropriately. Now, you could create these firewall rules based on the external public IP of each site. However, it's possible that one of your remote locations might also have a dynamic IP address, so you can also do these firewall rules by hostname, similarly to how I set up the WireGuard tunnel configuration. In order to do that, we will need to create an alias, which I'll be doing for this example. So we'll go up to Firewall and then down to Aliases, and I'll go ahead and hit the plus icon to create a new alias. And I'll name this WG Peers, and I'll leave the type at hosts. And then for content, I'll enter in the 2 fully qualified domain names for both of my remote site firewalls. So Site 1 and Site 2.0x2142.local. And then I'll go ahead and hit apply. Now, if you need to check this for any reason to make sure that those are being resolved appropriately, we can go over to the diagnostics tab and down to aliases. And then in the drop-down box, select our aliases that we created and see what those domain names are resolving to. Next, we can go ahead and create our firewall rule. So I'll go over to rules and then to WAN. I'll create a new rule, leave the action as pass, the interface is WAN, direction in, I'll set TCP IP to v4 and v6. And WireGuard is primarily a UDP protocol, so I will change the protocol to UDP. I'll set our source to the alias that we just created for the WireGuard peers. This will allow both Site 1 and Site 2 access to the VPN. For destination, I'll go ahead and set this to the WAN interface address. And then port range, I'll set to other, and then statically assign 51820. I'll go ahead and enable logging as well, and then save, and we can apply this rule. Now, while our tunnel should be online and active at this point in time, there is also a firewall group set up for all WireGuard interfaces, and you'll see that under rules as WireGuard group. By default here as well, all traffic over that WireGuard VPN will also be blocked. So very quickly, I'll create 2 rules that will permit all traffic, both in and out, across this tunnel. This will permit any source and any destination from the corporate side to Site 1 and the other way around. Now, because this is a WireGuard group, this will apply to both Site 1 and Site 2 as well. If you wanted to specify different rules for each individual group, you can do this by creating specific WireGuard interfaces per tunnel interface. However, we're not going to cover that in this video. I did do a video a little while back doing WireGuard remote client VPNs, and I did use this method for assigning firewall rules to those clients. So if you're interested, you can also check out that video for an alternate way of accomplishing this. Once that's all done, we've completed all of the configuration that we needed to do on the corporate HQ side. Similarly, we're going to have to create our aliases and firewall rules and WireGuard rules on Site 1. And so I'll go ahead and do that configuration real quick here. Once that's all done, we should be able to go back to VPN, down to WireGuard, and check our status. And now we can see that our remote peer does show that there is an active handshake and packets being sent back and forth. So let's go ahead and jump over to our Site 1 client PC, and we'll try again to ping that corporate file server. And sure enough, we can reach that 10.60.60.10 address. And just for fun, we'll go ahead and bring up a web browser as well and try to see if we can hit http fileserve.0x2142.local. And sure enough, we can hit that remote web-based file server. So it looks like all of the access that we need from Site 1 is all good and set up. So now for Site 2, we're going to do a full tunnel, which means that all traffic from Site 2 will be forwarded over that VPN tunnel, not just the traffic destined for the corporate HQ subnet. That means that if any end users at Site 2 wanted to go to the internet and watch YouTube videos or check the news or anything like that, all of that would be routed through the corporate HQ firewall, which means we could enable additional centralized filtering or other functionality there if we like. So we'll jump over to Site 2, and we'll go ahead and enable the WireGuard service as usual. We'll create a new endpoint for corporate HQ. We'll paste in our public key. And this time, what we'll set for allowed IPs is 0.0.0.0/0. This represents all internet traffic. And again, allowed IPs acts as a filter or access list telling OPNsense what traffic to forward across that WireGuard tunnel. So by setting this value for allowed IPs, we're telling it to forward all internet traffic. Anything and everything that someone wants to use when it hits OPNsense will be forwarded across that VPN tunnel to our corporate HQ firewall. I'll go ahead and set our endpoint address to corphq.0x2142.local. And again, just for fun, we'll set a keep alive for 25 seconds. I will save and apply. And before I go ahead and configure the rest of the Site 2 configurations, let's go ahead and bring up our Site 2 client PC real quick. And again, we'll double check that we cannot reach the file server at 10.60.60.10. And sure enough, that ping does not respond. And in this case, we'll also do a trace path to google.com. So we'll be able to see the different hops along the way. And as that progresses, we'll see a couple of hits to our default gateway, which is the Site 2 firewall.0x2142.local. Then the next hop we see is the internet router, and then out to the internet via Spectrum. So right now, all internet traffic from this client PC is being forwarded out the default gateway, out the firewall itself directly, and not through the corporate firewall. We'll see this behavior change once we get the configuration all done and ready. And so next we'll go ahead and finish up the Site 2 local side config. And we'll skip through this pretty quick, but a lot of it's the same. In this case, we'll name it Site2, leave public and private key blank as always. We'll set our listen port and our local IP address, and we'll add our corporate HQ peer. Then we'll go ahead and copy our private key. Now on the corporate side, when we create our endpoint for Site2, we're going to go ahead and name it for Site2, add in our public key, but in this case, we will be setting allowed IPs to 10.200.200.0/24. Because this is the corporate side, we don't want to route everything through Site2. We only want to route traffic that belongs to Site2 over that VPN tunnel. So we're only setting the subnet for Site2 here, so when traffic needs to go back to Site2, it knows how to get there. And we can finish up by setting our endpoint address and keep alive interval. We'll save and hit apply, and then go back to the local config for the corporate HQ, add Site2 to our peers list, save and apply here as well. Now on Site2, we still have to do our configuration for our aliases and firewall rules, but since we've seen that already, I'll skip through that pretty quick, and we can jump to the next steps. So real quick, once all of that is configured and done and ready, we can bring up our Site2 client PC and test access to that file server. And sure enough, we can in fact hit fileserve.0x2142.local. But if we do our trace path to google.com again, what we're seeing is we're hitting our default gateway, and then we're just hitting that WireGuard tunnel interface IP at 10.99.99.1, and the traffic is never making it to the internet. Now there is a reason for that. The traffic is being forwarded across that WireGuard VPN to our corporate HQ firewall. However, when the corporate HQ firewall tries to forward that out to the internet via its default WAN interface, that traffic is not actually matching any NAT rules, so it's not being natted to the correct addresses to be forwarded over the internet. And since it's not being natted, those internal only reserved IP addresses are being dropped by the upstream router. So if we bring up the corporate HQ firewall and go over to Firewall, NAT, Outbound, by default, OPNsense comes with automatic outbound NAT configured. But what this does is it just has our LAN networks, loopback networks, and management networks set to automatically NAT to our WAN interface. So we'll need to enable this as well for our WireGuard subnets. So in this case, I'll go ahead and set hybrid NAT rule generation, which will leave the automatically generated rules, but allow me to specify manual rules that will take precedent over those automatic rules. I'll save, hit apply, and then we'll go ahead and create a new outbound rule. Now for interface, we will leave this at WAN because the interface set here is going to be the outbound interface that traffic will use for the NAT. I'll leave this at IPv4 and protocol as any, since we're not specifying what type of traffic can be natted. For source address, it might be tempting to select the WireGuard network as all the source. However, if you keep in mind, for the WireGuard subnet and WireGuard network, it's actually that 10.99.99.0 range that is used for the tunnel interfaces. So that wouldn't work unless all of the Site2 traffic would be natted to that IP range on its way out from Site2. Instead, what we'll set to is a single host or network, and then we'll set the subnet for Site2, and that's going to be that 10.200.200.0/24. So I'll go ahead and enable logging, and then we can drop down to save and apply. And now we can see that we do have our one rule allowing 10.200.200.200 being natted to that WAN interface address. So this time we can go ahead and jump back over to our Site2 client PC. And if we do another trace path, sure enough, we are seeing a hit to our default gateway, that WireGuard tunnel address at 10.99.99.1. Then we're seeing as our next hop, the corporate HQ firewall, followed by our internet router. So we can be certain in this case that we are being routed through the corporate HQ firewall before being tossed out to the internet. And of course, as a final test, we can go ahead and bring up a web browser on the Site2 client PC, and we can browse to the fileserve.0x2142.local. So we're able to hit the corporate side resources, as well as we can try to hit google.com to ensure that we're still able to hit internet resources, despite all of our traffic being tunneled out to the corporate side. Okay, and that's all I wanted to show in this video. I hope that this video was helpful. Thank you so much for watching, and we'll see you next time.